Thank you. I appreciate the time to talk to you today about something that's probably unlike anything else that you've seen at this meeting. I'm the founder and CEO of Ocudyne, but I'm also, prior to this, I founded a heart valve company, believe it or not. So I'm not from ophthalmology, but you'll see why that's relevant here soon. So I want to talk with you a little bit about ocular perfusion. And today in ophthalmology, when we think about ocular perfusion, we think about the central retinal artery. We think about images such as this. We think about B scans, and we think about the choroid and stuff, and different sorts of views of the eye and how it is perfused. I would like to propose that we as a discipline here may perhaps include other arteries that are feeding the eye, including the ophthalmic artery, which I'd like to talk with you a little bit about here today. Cardiovascular disease and AMD, it's been discussed for 40 plus years, I think, that there's some sort of a correlation. You observe changes associated with smoking and hypertension. And recently there have been some discussions around the effects of endarterectomy on drusen and the like. Excuse me. It also makes sense, perhaps, that we consider the eye a little differently because every other organ system in the body has a perfusion model associated with ischemia and how that ischemia negatively impacts that particular organ. The thing that I like about this perfusion deficit mechanism of action is it explains everything. Hypoxia and ischemia is associated with the tyrosine kinase story, VEGF expression, complement, and FAS. So how would stenotic cardiovascular disease manifest itself in the eye? What would you see if ocular perfusion was an issue? I think we would see subretinal drusenoid deposits, a thin choroid, and geographic atrophy, among other things. We've looked at 259 human eyes. We've looked at cadavers, healthy controls, patients that died with AMD. Sorry, maybe coming down with something here, but an MRI study, again with healthy controls and diseased patients, a correlation study. The FDA has guided us in some of these studies, and finally we've actually conducted a safety study on a therapy that I'd like to discuss with you here today. You can actually see in some of the histology slides here the cardiovascular disease in the ophthalmic artery. We published a study demonstrating roughly a 50% loss in blood volume down the ophthalmic artery that tightly correlates with the progression of disease. So how does the mechanism of action in this therapy work? Basically, we've created and we use interventional devices to improve blood flow, disrupt the disease progress, and hopefully improve visual function. We have a series of guide wires, catheters, and balloons that have been custom made to the ophthalmic artery. And we come in radially or through the femoral artery and navigate up behind the eye and do a balloonplasty on the ophthalmic artery. You can imagine there's a lot of idiosyncratic kind of variability between cases here, but it nevertheless, we think, has done something. We attempted to treat 17 patients. We were able to treat 11 on patients with severe geographic atrophy. We had no serious adverse events. We had a number of non-serious adverse events that resolved and the patients didn't even notice, but they were found on follow-up treatments. And we had a lot of efficacy. Every single patient saw some benefit. I'll share a case with you here today, but reading speed improved, IVI questionnaire, the choroids thickened, geographic atrophy appears to have slowed, although that data, we're not quite as excited about that, not because we don't think it happened, just because of the quality of the images. And the CVI actually improved as well. I'd like to show you a 64-year-old female. You can see the nature of her AMD, the atrophy that she's suffering from is massive. And you can also see on the right, her ophthalmic artery. She has approximately 60% stenosis in her ophthalmic artery. We eliminated about 87% of that stenosis. We worked with Philips to modify a module that they have called the mean aneurysm flow amplitude module to demonstrate improved laminarity and roughly a 30% increase in blood going down the ophthalmic artery. We worked with them to modify smart perfusion to demonstrate that same 30% increase in blood flow making its way down the ciliaries. And this patient at 1 week saw an 11-letter improvement in visual acuity in the treated eye. I like this because the fellow eye also improved. Everyone complains about placebo effects, so we saw that here, but you see the fellow eye regressed back to the original measurement where the study eye continued up to almost 20 letters of visual acuity improvement. This patient saw 150% increase in reading speed, along with acuity and print size improving and the fellow eye doing nothing. The choroid got thicker. Anyway, there's a bunch of stuff there. We've got 40 patents. We've just weeks ago opened up an round of investment. We've taken in, I think, $1.5 million on an $8 million round. We want to get the product approved in Argentina. The government actually invited us to do it. after seeing the results. And we have spoken with the FDA and hope to be able to submit for an IDE here soon in the US. Some of our costs, believe it or not, are being deflected by some of the large strategic companies that you all, I'm sure, have heard of. And we have a kind of a plan that we can talk with you about at some point if you're interested. But if you'd like to invest and go on this unusual adventure with us, look forward to hearing from you. Thank you.
All right, really, really interesting approach and very different. Would you see this as a one-time approach, or would there be need for repeat ever?
We don't know. Some of the patients have been followed out to as long as 18 months, and we begin to see a little bit of a decrease. But, they're on average probably at that point, I don't know, 15 letters above where they would have been at baseline had they not been treated. So I think you are just sort of like shifting the loss out, but for a number of years. But as you know, these patients are very sick, and they're they're by definition at the end stage of their life. So,
creative approach. Thank you very much, Jeff.